Hello and welcome to Sampling Methods Day 2. It is mostly vocab, but there's a couple little things in there that are worth mentioning, so I made a video on this one, including what the heck a random number table is and how you use it. So let's get started. First one's a simple random sample. It's a sampling technique in which all samples of size n are equally likely. Then there's this sub-bullet, and the sub-bullet is the part that ends up confusing people. It says this is not the same thing as just saying that each individual has an equally likely chance of being selected. Now that seems like it is, right? It seems like they're the same thing. But say I have 500 people. 200 of them are men and 300 of them are women. Now, if I promise to sample 20 men and 30 women, right? Like I'm separating them out. Now, the first man, doesn't he have a 1 in 10 chance? And for the women, don't they have a 1 in 10 chance? So by doing this separation, right, like the way I sampled it, everyone still has an equal chance of being selected. But in this method, could you get all men? Could you get all women? You couldn't, right? Like it's not possible. The way this has been designed, you will specifically get 20 men and you will specifically get 30 women. So not every sample out of the population is possible. A simple random sample, any combination is possible and they're all equally likely. So it's a subtle difference, but it is an important one. To create a simple random sample though, and this is why it's called simple, it's the simplest one to make. Label every member, randomly select them, and those individuals are in your group. That's all you do. The random selection can happen a few ways. You can use a random number generator. You could use a random number table, which is stupid, but sometimes you have to do that for AP stats. You could draw names out of a hat. You could do something really, really clever. What was it? That one person said that they were going to put everybody in a pen. They were putting all of the entire population in a very, very large pen, and then they were going to use a giant claw machine to randomly select individuals. Technically, that'll work. It's a little weird, but you could do it. A stratified random sample. It splits the population into groups of like individuals called strata and chooses a simple random sample in each of those groups. That's what I just wrote over here, right? I split the population into men and women and then selected within the men and women. So this is a stratified random sample. The only reason you would do a stratified sample is if you have a reason to believe that they may answer differently, or if you're doing an experiment, they may behave differently. So if you're talking about height, probably makes sense to break up men and women because men tend to be taller, right? If you're talking about income level, well, maybe that's a bad example. School grades, I don't have a strong reason to believe one would be higher than the other, right? So it wouldn't really make sense to split them. You could, maybe there's some hidden thing that you didn't know about, but if you don't have a compelling reason ahead of time to split them, there's really no point. Cluster sample. Splits the populations into groups based on location called clusters and randomly selects a few clusters. Then uses every member of that cluster as the sample. The major advantage. So again, it's mostly geographic. So say this is Orlando and we've got Winter Park. I guess I'm doing Orange County. We've got Winter Park. We've got College Park. We've got Eatonville. We've got, what's over here? Paramore. And then South OBT. We got your Delaney Parks, your Wade View Parks. We got like all that stuff. And then whatever's down here. Stuff. I guess this is Holden Heights. And then stuff that I just am done labeling. I'm sorry if you live there. A cluster sample would just pick a couple of those groups and take all of them. in that group. So maybe you randomly select Winter Park and College Park and Wadeview Park. Now, if you stop and think about that for just a moment, who lives there? Y'all rich, right? Like, if the people that live in those places are generally fairly well off, right? So that may not be representative of this entire area. So advantage, I guess that's the disadvantage, right? The disadvantage is it may not actually be that representative. The advantage is it's easier. I only got to go to a couple places. I don't have to go everywhere and talk to people in every group. I only have to talk to a couple groups. That's literally it. The advantage is it is just easier to do, but it's not as reliable. I've missed this one. I'm making guided notes. Sorry. Systematic random sample. You select a sample by randomly selecting one of the first K individuals. I think that this kind of does it for you. If you have 200 people and you want a sample of 10, first do 200 divided by 10. That's 20. So randomly select out of the first 20 and then do every 20th after that, and that'll get you your sample. Variability. So we always want to choose methods that will produce low sampling variability. Sampling variability is just the variation that we get from doing things over and over again. We wouldn't actually do that, right? Like, we wouldn't actually do the same sample over and over and over again. But it's useful to talk about the variability if we would do that, because if we have high variability, that means we aren't really sure our guess is a good guess. If we have low variability, our guess is probably a pretty good guess. It might still be bad, but there's a better chance that we did a good job. The best thing to reduce sampling variability is good stratification. There's not a whole lot else you can do, but that'll reduce your sampling variability. All right, random number tables, they're just annoying, right? Like, in the modern day, we would not use these. We would use a random number generator, which you could make an argument that computers aren't truly random, but like, they're pretty good. Like, as far as we're concerned, it's more random than a person is. But what a random number table is someone put digits 0 through 9 into a hat, and they drew one out. And so say it was a 2. And then they write down a 2. They put that slip back, shake it up again. They draw another number, and this time they get a 4. And then they get a 7. Then they get 2 4s. Then they go to the next set. They usually write it in numbers of 5, in sets of 5, just so they're easier to look at. Then maybe they get 6 1 0 0 3. That's all it is. It's completely random numbers. And truly, yes, this is more random than a computer can be. But it's stupid. I hate it, but oh well. Let's show how to use it. You want to sample 5 students from a group of 100 students using the random numbers below. So I don't know why I just zoomed in, but I did. Okay, if I want to sample 5 students from a group of 100 students, the first thing I need to do is label them. Now, you could label each student one through 100. But then here's the problem if I do that, because we have options. We can do other things too. I would need to take a 3-digit number, right? And I get 111. What do I do with 111? Right? Like, that is just a wasted number. So if you're going 1 through 100, what's nice to do instead is you label them 00 through 99. Right? Each student is labeled 00 to 99. And now I'm just drawing 2-digit numbers and everything's covered. Read 2 digits at a time. Until we get 5. Nope, I don't know why I wrote can. We get 5 unique numbers. And unique is important, right? Because like if I got 36 twice, I don't want to use the same person, right? So saying unique says I'm going to ignore repeats. I'm going to write that in parentheses so you know what I mean when I said unique. These 5 students are the sample. Now, when you define how you're going to use the random numbers, it has to be so specific. You have to, like an idiot should be able to read your directions and do it. And if an idiot can't do it, then you need to reevaluate. Okay, so now we're just going to do that. Read 2 digits at a time. 11. 11 can be in my sample, that's fine. 16. That's okay, I can have 16. 43, I can cross that gap, that's okay. Like I said, they're just in sets of 5 so that I can see them easier. Okay, and then 63. And then 18. And I didn't get any repeats, so I'm good. That just is my sample. Student 11, student 16, 43, 63, and 18. And that's it. Bye.